we just present this as one, option.
And I want to make a quick point that this isn't like a design where we're saying build the organization like this. This is a mapping exercise. This is an observation of what is happening and how the functions relate to one another to provide context for our work, which resides largely inside that fraud detection and defense box. But we want to make sure that any implicit policy making that we're doing is in discourse with the stewards who are responsible for policy making within the ecosystem, and that any data that we're getting from the platform and or data we're pushing to the platform kind of connects to the team that's responsible for operating the platform. So I don't want to spend too much time because we could do a whole session drilling layers of the Gitcoin ecosystem, but the idea here is to make mapping tangible, not just say, oh, we make maps. Like, we make maps to contextualize models, and we use models to help inform decision making. I don't know if you want to jump onto the next section, or Jeff, like what you think in terms of...
Yeah. So the next quadrant, we're going to look at it again. Each of these is a rabbit hole. We can talk about it, but we just want to make sure there's enough time for the other two talks before lunch. So the next section we're going to look at is model, present, debate. So we are communities coming together to make decisions, right? These are commons. These aren't top-down, corporate structures where we are imposing our decisions. We have to use these tools to discuss with each other what is best for our commons. And it's amazing because this is already happening in the wild. The OneHive community, Luke Duncan in particular, Sem, also masters of cadCad and using these tools to make decisions. Luke put together this incredible proposal. We worked with him on the Luna Swarm to model, well, I guess that was conviction voting, but he was modeling basically a dynamic issuance proposal for the Honey token and did all sorts of different analyses to understand how different issuance policies would impact various things within the ecosystem, and of course, modeling everything. We can start with an iterative, start with a small model and iterate from there. But he made some data-driven analysis and then put it forward to the community that this was a proposed Solidity implementation. So basically what he recommended, he modeled in cadCad and then had a Solidity like smart contract implementation within this proposal. The community voted on it, and then they moved forward with this.
So what I think is important here is not necessarily the particular system or the particular policies that were being recommended, but the fact that the person who was making the recommendation made an attempt to both explore some of the consequences of the parameters and to make that available to the community to discuss. So here, in a smart contract design setting, most frequently what you see is people behind the scenes, they make some decisions, they might even do some modeling and analysis. There's no discourse. They're not saying, hey, look, I explored it, I think there's some trade-offs here. Here seems to be the consequences to the best of my knowledge of the trade-off decisions. Here's what I or we are thinking, and then actually puts out there not just the recommended Solidity code or the recommended parameters, but the equipment that they use to come to that conclusion. It invited discussion, invited criticism, and there were multiple calls and meetings and discussions, and people ran through and even in some cases made their own versions of the simulations because they're in an open source repo, and that they could converge on a willingness to deploy the new contracts from a place of discourse rather than from a place of, well, I'm the developer, I wrote the code, take it or leave it. And I think that's relatively unique in the Web3 space, but I think it's critical if we want to think of these systems as participatory.
And here's another, this is fantastic because this continued with another member of the community said, hey, what we modeled and what we did was great, but it's been 6 months, we've learned some things. I'm going to take that model and I'm going to iterate on it and suggest improvements. So here is a secondary sort of iteration on the computer-aided governance proposal within the OneHive community, suggesting some parameter tuning according to what they've seen. And of course, there's community members weighing in, some discussion with data backing, like the types of parameters chosen, the decisions being made, and this is all happening in the wild. This is just going on in the OneHive community in particular, but this is the kind of sort of data-driven policy that cadCad can underlie. So
I guess we should probably move into the sort of debate and act and monitor, because you've already started to hit on those concepts here, because although, in this case, the discussions led to the eventual ratification of that particular issuance policy and the monitoring and evaluation of it, we were going to jump to one more example where we did some work on a model for a sort of credit money token, a token that represents a stable or sticky coin that that serves as a medium of exchange in a more meaningful way. This one in particular was with a client called Reflexor Labs. The token is called RAI. It's based on some of the early designs for Maker's DAI before they transitioned to a hard peg. But we did a variety of analysis with their team leading up to the parameter selection for the deployed contract. But here we're emphasizing that there's data being pulled off of the live net, and in particular the feedback loop between the expectations, right, the design and the design analysis, and the deployment and the observation of the real data from the real system. So what Jeff is showing here is sort of a summary post about some of the evaluation and statistical testing that went in before the network was launched, as well as some links to data collected post-launch. And the models associated with design for this were recently open sourced, and the models for monitoring and tracking I think are at least maybe open source in the future at the discretion of the client. But as much as possible, we want to put these things out into the open so people can build on them, learn from them, fork them, either use them for the monitoring and maintenance of this particular protocol, but also for learning how to apply this kind of data-driven modeling to your own ecosystems. I don't know, Jeff, do you want to kind of speak to the feedback loop between debate, enact, and monitor, and kind of closing the loop between intent and outcome?
In context of RAI?
No, just in general. I can speak to RAI.
I'm kind of drawing a blank, actually.
Sure. So I mean, I guess maybe what I want to emphasize here is the separation between intent and outcome. And we don't have to speak to it in the context of RAI specifically, so just an understanding about complex systems or systems in general. There's a big difference between having a debate, deciding to do something because you think some outcome will happen, and actually checking whether that outcome happened. It's really easy for us to come to consensus that we want to do A to get B, and then for C to happen. And what do you do then? And I think, for starters, you have to be prepared to accept that that's not only like possible, but likely. That you're almost never going to get exactly what you expected. And so closing the loop from, hey, we debated, we concluded, we even decided and deployed a solution, to actually putting in the monitoring infrastructure to see whether or not you're actually achieving that goal, that purpose, and feeding back this process. And it can be a short loop, like, oh shoot, it didn't do what we expected, go back to debate and maybe roll back the decision or make a new one, or it might mean going all the way around the loop again and asking new questions, something fundamental maybe was wrong in our way of modeling. And so the whole reason this is a loop, and it's actually really a loop of lots of little loops, is because you're trying to make sense as you go. You're mapping while you're modeling, while you're deciding, while you're evaluating. And that's the kind of reality of making sense of a complex world. So it's more of a process and less of an object. You're not done. You're always doing it.
So this is the Common Simulator. This is a way for the Common Stack put together basically a better UX, dealing with cadCad. I mean, it's deep in the data science rabbit hole. You're not used to seeing books of data and graphs and plots. It's not very user friendly. So we created this simulator as a way to take the outputs of cadCad, the inputs and the outputs, and embed them in a user-friendly simulation game. So we can understand and our purpose in this was to give people a feel for the parameters of these various components, how you're parameterizing them, but doing it in a fun way. But hopefully, this UI, or maybe not exactly this, but similar thing can be used to, make it a little bit easier to input data into these and understand the data coming out of them. So it's not just for the data scientists and math nerds who can understand Jupyter, Python notebooks and so on. So you have come back in time. You are armed with cadCad to be able to run futuristic predictions on how things are going to turn out. So we are going to instantiate a commons for the radical exchange movement. We have gone back in time to...
We should probably make a little bit of a break, because I mean, just to make a leap, that was a hard transition. So we were talking about a framework for thinking about decisions. Now we're talking about instantiating a model of something so that people can have an experience of engaging with a tangible thing. So the Common Stack built this Common Simulator game, which matches up to some of the parameters in the specific sort of design, the garden's design essentially, the tooling that's used within the common stack. And so there's a kind of cadCad model of the class of system that the common stack is working on in order to give people the opportunity to play with the parameters and see various outcomes of a set of simulations, but wrapped in a sort of role-playing game. So it's a lot more constrained than the sort of open scientific framework, but it's also a lot easier to engage with, build intuition, to start to play with simulations, to sort of understand the role they might play. So I just want to make that leap because I think it's a transition from a scientific process to a didactic process. So we're talking about the deliverable of the didactic or the teaching type as opposed to the deliverable of the sort of, how to build a scientific experiment that you use to evaluate a particular set of decisions within one of these systems. Sorry.
Okay. So we've put in all our data. It's now churning behind the scenes. This UI has sent all of the inputs to the cadCad model. The cadCad model is now crunching that, and it's going to send the outputs back, and it's going to give it to the user in a way that is, understandable. Here we go.
Jeff, how do you choose the parameters? Because you were doing it very fast.
You can read through with more detail if you like. I'll share this link as well. This is a game, so like it comes out with a score saying how good you did.
Choose it randomly to make an example.
Just now, yes.
Okay.
Yeah.
No pressure.
So here's some outputs. So how much was contributed to the funding pool, and you can run temporal simulation. So it's not just a one-point answer. It's like, how does this do over time if you had these type of agents? So this is taking agent-based behaviors into account and their interest in participating or their sentiment towards this commons. You can incorporate all sorts of different behavioral models and different agent-based profiles and so on. Here's the sentiment. So how do people feel about this commons? If you feel good about it, you're likely to buy more tokens. You're likely to contribute more. If it's not producing a lot of things, then your sentiment drops. So you can model these types of things. Your token price, far less interesting.
Honestly, Griff might be a good person to give a quick shout out about that, because you largely designed the scope of this to address the questions that people were asking about the work you were doing.
Yeah, you did a great job.
Good job, Griff.
What we learned, randomness is better than design.
It's all how you set this scoring, right? So we set it so that about 2/3 of the time you saved the world.
Very realistic.
So we rigged the common. But
You rigged the common.
yeah, we rigged it. For sure. In the end, this is definitely more of a narrative. Like it really is running cadCad in the background, so there's authenticity, but it's running one simulation. Okay.
Yeah, the emphasis here though is how you frame and tweak the thing. It matters a lot. So one of the reasons why the focus of this talk was on computer-aided governance rather than cadCad, the tool for running a simulation, is that look, if you know what you're doing, you can make it say whatever the hell you want. That's not the point. Here, Griff and the common stack made a teaching exercise that was meant to be fun and make you feel good because you saved the thing.
You nailed it.
Yeah.
Nailed it. But the notion of the computer-aided governance is more about taking into account how you frame, how you measure, what assumptions you take, so that it hopefully pushes back against a politics characterized by people just framing the problem in a way that gets them the answer they want, rather than participating in framing the problem to try to discover solutions. And that's a big leap, because I think naturally what you see is people coming to conclusions based on whatever their own process is, then working backwards to make arguments for those things, rather than working together to find framings and sharing ideas at the slightly more basic level and sense making together. So what we're actually trying to accomplish with the exploration of this CAG, computer-aided governance thing, is to help people work together at the sort of more fundamental, more scientific level, where we say, what are we assuming? Why are we assuming it? What context are we in? Is this the right model for that context? And actually work together to make data-driven decisions, rather than merely use data to justify the points that they want to push for in a political setting. It's still political, all of the framings are effectively, but when you acknowledge how much power decisions about assumptions and context and mappings have, you can't exclude them from the discourse. And so we're trying to dig in and say, let's work together. What context are we in? What assumptions are we making? When is that the right answer? Not this is right and this is wrong, but under what circumstances does this make sense? Are we in those circumstances? Are we still in those circumstances? It's more process-oriented and less sort of solutionist. There's not like an answer forever. There's a process of discovering whether what we're doing is working. Does that make sense? And for me, at least, it's a huge leap away from, I guess it's sort of like declarative politics, where like we must do this, to like continuous sense making.
And honestly, that was almost the main point of the common simulator. It's like this story that shows people how to do design and how to, it's like, it's not someone from the future picking all the parameters for the people, but it's someone from the future coming in and helping the community choose their own design, right? And telling them, okay, if you choose those parameters, here are the results that we're simulating. But in the end, it's the community choosing everything. And then almost like computer-aided advice process, right? Where it's like the computers are telling them what some potential outcomes could be. But
And projections aren't predictions here, right? So a projection is an extrapolation. It's going to get worse the further you go into the future. But what you're doing when you include a projection process is giving you a forward look. So when you think about data science, it tends to be very backwards. Look at the data and you see in your rearview mirror. When you do simulations, you're really projecting. And so you're doing this sort of look backward, look forward, sit in the present, try to make sense of what to do now. But again, you don't say, okay, well, I simulated, therefore this will happen. You're continuing to loop through, and you act, and then you monitor and ask and keep looping. And so each time you're going to look maybe forward in a different direction, or maybe some new facet of this complex system is going to become apparent to you, or even become critical to you, but you wouldn't have known until you got there. So it's a kind of putting both the forward-looking and the backward-looking together, and still using the data and the computers to inform decision-making without using it as though it sort of gives you guarantees. And there's a term, Jeff, you kind of called this out when I said it yesterday. Objectivity fetishization is very common in people who use computational or data-driven methods. And the challenge here is not to throw out the baby with the bathwater. Like, we need the computational methods, we need the data, we need the mathematical models, we need the simulations, but we can't sort of give them this objectivity fetishization, because as long as we acknowledge that all models are wrong and some are useful, then there's this deep sort of subjective sense-making process that comes along with it, making assumptions and framing problems, which informs the conclusions. And so there's maybe a really important, I guess maybe the point I want to leave you guys with is to retain your sense of the subjectivities without discarding the tools that maybe are sometimes overly associated with objectivities. And that's why we're presenting today, is to say, look, we've got data and machine learning and all sorts of great technical tools that look backwards. We've got simulations and projections and tools that help us look forwards, but both of those are still they still have some inherent subjectivities, and so if we want to apply them, we have to apply them together through, again, discourse and have discussions, ask why assumptions are being made, and ask what the consequences of those assumptions are.
Yeah, so we're going to finish up quickly or shortly here. I just wanted to say one last thing. cadCad is an open source community. cadCad is a commons. There are a handful of core contributors. So on our website, we have this. Some of this is broken down. Actually, we're doing a revamp of our website. cadCad is still vast majority supported by block science in that they pay a bunch of resources. There aren't a ton of people who know how to use this software, but anyone who wants to contribute, we have had some pretty impressive community members come in and either contributing to the core code base, or using it in a whole bunch of different contexts. Because ultimately, before this tool gets really useful, is we need a library of models. So people don't have to start from scratch. You could just take the common stack conviction voting model, for example, and use that to model that aspect of your system. You can then combine it with your augmented bonding curve, or your honey dynamic issuance policy, or your quadratic voting, or your quadratic conviction voting. You know, this is this modular model library, and it's not just smart contracts, it's also models to be able to properly parameterize in context your smart contracts. So this is kind of another library, the model library and the smart contract library.
Right now, the stuff that's available in the demos and tutorials, we have like a predator-prey model and some other more like canonical educational models, because some team members built them to try to help train people to use it. It's very general, it's just dynamical systems, so there's everything from, you know, signal processing and control theory to you know, ecosystems. And although we only have a kind of random sampling of models as a demonstration, to Jeff's point, probably the most powerful way to make it valuable is just people grab it, learn how to use it, apply it to something that interests them, either a practical example or an educational example, and just put it in the open source repos and make it available to others.
So I'll share all of these links if anyone wants to follow up. There's a cadCad Discord, there are 3 cadCad working groups, there's Core Tech, there's infrastructure admin, and there's education outreach. So we need to tell more people about what these things do, we need to train them up in how to do them, and also continue building the code base to be a more robust tool.
Yeah, it's time for questions.
Sure.
Okay. So I have experience with NetLogo and also with ACE. It's the agent-based simulator on Python that was done by Donny Farmer and other guys from the Institute of Economic Thinking. And there was, yeah, like my question is like, what are the main differences? And the second question is about.
Can we answer the first one, then
Okay.
Because I always lose track of the second one. All right, so first question. The most important answer is that cadCad's not actually agent-based modeling or system dynamics modeling. It's actually kind of a meta framework for scientifically controlling things. So being very clear about what assumptions you're making, tracking the metadata, running many experiments. So you can actually wrap objects from various other frameworks. So if you wanted to put parts of models from other frameworks inside of a cadCad model, you can. We use a lot of the time, we'll write mixed models, multi-scale models, where we define, you know, arrays of agents and behavioral representations of them, but then we'll also represent system level or system level dynamics, which is interesting because, at least for my background, I use both agent-based modeling frameworks and system dynamics frameworks, but they tend to not work together very well because they have different scales of representation. cadCad is sufficiently general, but it doesn't assume a scale of representation, which means that often the models that we build, and I think the conviction voting model is a good example of this, we have multiple dimensions of variation, including characterizations of the system level state and characterization of an agent level state, and you can see interscale feedback, where the individual actions of agents sort of have an accumulated effect on the system or the environment, and that environment state has an effect on the agents. And so that kind of multi-scaling effect is very difficult to represent in agent-based modeling frameworks because they don't have a good way, short of hacking agents that are representative of the system, to represent system state as co-evolutionary with agent-level decision and agent-level state. So that's one of the reasons why we don't just use the existing tools. The other, I guess maybe to go back to my first part of the answer, the emphasis wasn't necessarily on the specific system structure as much as the meta structure and the ability to run, you know, make changes to the assumptions, make changes to the designs, run loops of large experiments, and then collect data about the consequences of your choices. So it's that outer computational scientific process that we actually invested time and energy in supporting. So controlling Monte Carlos, parameter sweeps, A/B tests means swapping out whole components of the code and seeing what happens if I say, took one behavioral heuristic and just swapped it out for another one. And that computational science workflow is actually often done very weakly because the tools would force you to write separate models, or it becomes difficult to build I guess, data sets of consequences of assumptions, because that means you have to have multiple models. And so by parameterizing the cadCad models the way that we do, we actually run what is essentially meta experiments. We run arrays of experiments and then look at how sensitive the results of the experiments are to the assumptions or the design decisions we took.
Do we have any other quick questions? I just want to not monopolize all the rest of the time before lunch because we have 2 other cool calls, or talks, yeah.
So
Everything is cool.
this is very useful for, at least on how it was demonstrated here for the parameter search, right? It's like, okay, we are designing and modeling something, what will happen with these parameters. But during the simulation, the parameters are actually set up as immutable. So have you considered the fact that we can actually cybernetic loopholes, where you actually are setting up what you want, and you then adjust the parameter just to make sure that the result is actually the same.
So you can do that. It's actually really a matter of semantics, because in order to do that, I simply move the thing, the parameter that's going to change becomes stateful. So I move it from parameters to state, because when we say parameter within the software, what we mean is thing that's immutable over a single run. But if we want to represent a parameter that can change, we just move it into the state object. We might call it, variable parameter 3, making up a name, but then variable parameter 3 is a thing that under certain circumstances will mutate. And so it has to be represented as a state because it can change, but it can still, that state can represent a parameter in the sense of the design, just a parameter that's mutable.
So it is possible to set up like a wish curve and then